Hi, my name is Paras.
Hi, I'm Gopi Ravuri.
Shilpa Akula.
Swetha Gunamgari.
Hello, my name is Vishnu Nalluri. We are group 5 members. And today we are here to present artificial intelligence system for the class. Today we are here to present artificial intelligence system for the class Global Technology, year 2007, spring semester. Is it fall? I'm sorry, it's fall semester. Okay. I'm pretty sure so many people must have presented artificial intelligence, but here we are with something new in it. I hope so. So, artificial intelligence is a key technology in many of today's novel applications, ranging from banking systems that detect attempted credit card fraud to technology systems that understand speech to software systems that notice when you're having problems and offer appropriate advice. Well, these days most of the banking systems incorporate artificial intelligence, which if you use your credit card too often, and if you don't use your credit card for a while and suddenly there's a huge amount of withdrawal, artificial systems will block your credit card, which is done automatically. Next slide. Well, I have a definition for artificial intelligence. It says artificial intelligence can also be said as a branch of computer science in which design and implementation of intelligent agents are done. That's self-explanatory. It is a design process of intelligent computers that can act as a human with intelligent behavior. So here we are with roots of artificial intelligence. I found a couple of roots for artificial intelligence, starting from philosophy, logic, mathematics, computation, psychology, biology, and evolution. And I'm going to explain this to you as we go on. And there's two broad categories for artificial intelligence: is classicalism and connectionism. Classicalism is more like a rapid formulated mathematics. It does the calculations, and we come up with an appropriate answer. Examples, practical applications would be chess, weather pattern, and connectionism would be more like human behavior, where you learn and you interact, which is mostly done by neural networks. And subfields of artificial intelligence, neural networks. Well, we have here brain modeling, this time series prediction classification. Evolutionary computation is more about genetic algorithms and genetic programming. It cannot be taught in a day. It has to be evolved in a series, or it should have pre-designed information in it to understand genetic algorithm. You cannot teach an artificial system just go about understanding genetic programming. It has to have a preset of information in its program. And we have vision, object recognition, image understanding. And the best practical example for vision would be DARPA. It's called DARPA. It's a US-based military program where the automobiles are run without anyone, and mostly it's fly-by-wire systems. So the vision system is very much in place right now. Okay, further we have robotics. Everybody knows about it. We have expert systems and speech recognition, speech processing. Speech processing, I think Vista has a best speech processing in our operation systems, along with Dragon. And I also noticed that if you call somebody from T-Mobile or Verizon, a computer picks up the call and you need to speak to it, and it understands your language. That is mostly done by speech processing. Natural language processing, planning, these are further subfields. And I'm going to explain about machine learning later on. Elements of AI, machine learning, decision tree, problem solving, and knowledge representation. Okay, what is machine learning? Learning denotes change in the system that is adaptive in the sense that they enable the system to do the same task drawn from a population of similar, more effectively the next time. So it's all about learning and performing better. Types of learning, we have rote learning. It's like memorization, supervised learning. We have a set of rules, and unsupervised learning, that's automated learning. And this is rule indication system. It's self-explanatory. You create an initial set, then you have a training instance. You generate a new and old rules. You evaluate, and you filter the rules. If it's good, it'll finish. If it's not good, it'll take you to the second step. It's just a simple flowchart. Decision tree. This is really important neural network. A decision tree is a tree structured plan of a set of attributes to test in order to predict the output. The decision, to decide which attribute should be tested first, simply find the one with the highest information gain. Okay, here we have a simple logic thing. We have outlook. If it is sunny, we have 2 more questions. If it is rainy, we have 2 more questions. If it's overcast, that's optimized. You can go out. If it is sunny, then again humidity. If it's high humidity, you stay in. If it's normal, you go out. So in this way, you can actually predict whether you're gonna stay in or stay out depending on the weather information. Okay, here I'm handing over to Paras.
No, I can stay here and just.
No, you need to go there.
Basically, artificial intelligence is about that the complex problem will be solved by the intelligent machines, and I'm covering about the problem solving in artificial intelligence. So, what the problem solving is to achieve acceptable solution or a goal that we reach any goal with the use of artificial intelligent machines, and we should define the problem like the problem should be in a narrow in focus and clearly defined. And every problem should be represented by some knowledge to the system so that they can understand it. And so problem solution guided by knowledge and specific situation, and it depends on the situation also. And the example problem solutions are the winning move in the chess game, finding a route like finding the path, and placing the components in VLSI PCB. That's like a motherboard, and we can place the machines intelligently by the computer systems at the appropriate place. So there are around 6 steps of problem solving. Like one is the problem solving is the well-defined problem can be solved intelligently by the computer machines, and the problem should have the initial state, and initial state that is let's say this is a path that we need to reach from this to the this is the initial point, and this is the goal point, and so this is the initial state, and the state space is the whole diagram is the state space, and actions means to move from one node to another node. So moving is called action, and the goal test is that is the goal state has been reached or not, and the solution is the path from the initial to goal state, like this is from this node to this one. So the computer system will automatically calculate which is the best path to go from the source to the destination. And there are 2 types of problem solving methods, like special purpose method and general purpose. Special purpose is very specific and for specific application only, and the general purpose is it can be used for many different systems. So basically the problem solving is done by the state space search. From here the search algorithm will start and find which is the best path to reach to the destination, and that is called the state space search. And states are used to represent the snapshots of a problem. Like any problem can be represented by using that kind of snapshot, and operators transform from state to state. So the main we called to move from this one to this node, and from this one to this one, we call it operator. And finally the best path is selected. So the search techniques, there are many kinds of search techniques to go from initial to the destination. So one is the heuristic search. So it is search by learning. This is not the best, but it guarantees a solution.